Hi, this is a wrap-up to Chapter 6. Okay, this is the fourth of our video lectures on this chapter. And I just walked you through models 1, 2, and 3. Please know these intimately, friends, okay? And let's wrap up with a discussion about generalities, okay? Now, the Gordon model is very, very simple, okay? And yet it won its inventor accolades in the mathematical and financial communities. Because what he did is he took an infinite stream of cash flows. How can you take something infinite and put it into something so easily measurable with three different factors to solve for in one result, okay? The best way to put this is something called Zeno's paradox. Zeno of Elea was a Greek philosopher, and Greek philosophers many times had way too much time on their hands, and they'd play mental games inventing paradoxical puzzles. And these puzzles have become very important to us as we study artificial intelligence, because if you can't solve something by deductive logic in your own mind, it's hard for you to program a computer to do the same thing. So, you know, a lot of this has been played up in science fiction movies. I can think of a couple of Star Trek episodes where they did something like this. Okay, so Zeno basically said, if there's a tree over there and I'm an archer and I shoot an arrow at it, mathematically that arrow can never hit the tree, because think about your math friends, before something can get to the end, it has to cross half the distance. Then it has to cross half of the remaining distance, and then half, and half, and half, and half, and half. And you can subdivide by half to an infinite degree, okay? So Zeno said, theoretically, because you can always subdivide by half, the arrow never really hits the tree. And of course, that's interesting. It's a fun game for your mind, but we know darn well that we don't want to be standing between the archer and the tree, because we know in real terms that arrow physically does hit the tree. So that's Zeno's paradox. Okay, so the reason that that's relevant here, aside from just being a little fun thing to imagine, is because it has to do, the secret of solving infinite streams of cash flows in Gordon's mind had to do with Zeno's paradox. Only because of the element that we call PVIF, the time value of money factor that has to do with table B, I beg your pardon, the PVIF, present value interest factor, with one little glitch. Now, if it weren't for Myron Gordon's formula, then, and by the way, this wrap-up chapter contains nothing you need to know for sure for the quiz, but what it does do is it will confirm in your mind, it will firm up everything about all the topics I covered in models 2 and 3 specifically. So for that reason, please hear me out on this last wrap-up lecture. Okay, so this is what Gordon's, the pre-Gordon model to solve for an infinite stream of payments would look like. Okay, I don't know about you, I don't want to try solving that. Okay, but here's what Gordon rationalized. He said, the point about this growth, keeping in mind that G is the growth factor, is that it's going to happen in the future. So, the further out you go in the future, the more of a benefit discounting has to you, as you saw in the past in Chapter 2. So, the more you move toward infinity, the greater the impact of discounting. In other words, if you want to grow to $10,000 20,000 years in the future, you can start with a fraction of a penny now, right? Okay, it works the other way too when you look at how it reduces. So let me show you something. After a certain point, hold on, Gordon said, you can ignore it. Okay? Here's a company called Achilles, and I call it that jokingly because Zeno did not use an arrow in a tree. He used Achilles and the tortoise. Achilles, a very fast mortal, raced with a tortoise, and of course, after giving the tortoise a head start, Achilles had to cross half the distance, and then half again, and the tortoise is always gaining. So theoretically, he never catches up with the turtle, now does he? So, all right, this is how a dividend grows. Now, you've got a constant growth, dividend growth stock, so the upper line shows you how the actual dividend is growing. I really accented this for dramatic effect, okay? Now, here's where Gordon came in. Gordon said, yeah, that thing can grow to infinity, but because the more you move out, if you discount it and look at its present value, the less you can start with. So this line, the lower line, no matter how much that dividend is growing, time is amplifying the effect of discounting, and you can start with less and less. So Gordon said, therefore, that number, that line rather, is going to come infinitely close to the x-axis, and after a certain amount of time, therefore, you can ignore it. Even though it goes to infinity, the discounted value becomes so tiny, who cares? That was his point. That's the crux of the Gordon model. Okay? So that is why we can ignore those factors and say the infinite can be measured in finite terms if and only if you discount. That simplifies things for us. Instead of this infinite stream of payments, ladies and gentlemen, we get the Gordon model. As long as R sub S is greater than G. Otherwise, that line has problems. Okay, so Gordon actually simplified things. That line is called an asymptotic line. Please do not bother memorizing that, okay? But a line like this, bottom line, that infinitely gets closer to the x-axis but will never, ever, ever touch it. It'll always be just the tiniest, minutest fraction away from touching it. That's called an asymptote, and that's why Gordon works. We can ignore it. He basically says it's so small. Do you care? Of course not. All right, so to illustrate that, friends, I left you with a couple of little mind games here. We've dealt with practical math in this course because it is a practical course. Okay, so let's assume that you can discount $1,000 for 60 years. Okay, we haven't dealt with numbers quite that big yet. But 5%, $1,000, 60 years, how much do you need now? Okay, how about 100 years? How about 170 years? The greater that number of years gets, the less you need to start with now. 60 years means to get 1,000, you only need to start with 53 bucks. 100 years, only 7 bucks. And 170 years, you only need to start with a quarter. Amazing, huh? Math it out, you'll see that it works. The only thing is, remember, you've got to start with something. Zero can't become something non-zero. So the present value, no matter whether you go centuries into the future at some very tiny interest rate, the point is you can't start with zero. Even if you start with 1,000th of a penny, you must start with something now. That is the bedrock upon which the Gordon model is based. Okay? Once again, anything coming out of this lecture is meant to affirm and solidify your understanding of this math. I'm not going to quiz you on anything related to this fourth video lecture. It'll all end at my third one, the one I just did prior to this one. Now, some people will say, well, what about non-dividend paying stocks? Some stocks don't pay a dividend. How do you calculate that value, Mr. Gordon? Okay, well, it becomes more problematic, but what you do in this case, dealing with more complex models, and this is a subject for a more advanced course of study in this discipline, you look at the underlying intrinsic value of the company. Okay? Remember, paying a dividend is actually lowering the share value to a certain extent because the company, by the extent of that dividend, is not reinvesting that money in its growth. So investment experts play games with aspects like that and say things like, well, let's say, what if the cash could have been paid? Let's assume, let's simulate what the dividend could be. Apple, for example, until about 10 years ago, I think, or 12 years ago, did not pay a dividend at all. Okay, and yet its stock had a value. Sometimes analysts will say, what would the cash flow upon liquidation be if this company were to wrap business up today, pick up their bat and ball, and go home? Okay, remember, required rate of return, R sub S, always has to factor in. Okay, so the company, if it's a non-dividend paying company, will have to go through supplemental exercises to determine what its dividend might be. And that might be becomes the basis of a valuation model. Again, that belongs in your future if you pursue a more advanced course of study in investing, which I hope you do. Okay, finally, the last topic in the chapter, as stated, I will not hold you responsible for this. You all know that when you are given an algebraic equation, you can solve not just for one thing, like we've been solving for p sub 0 throughout this chapter, but you can solve for anything. I'm not going to ask you a question like this, but for example, you might have to solve for D1G, or in this case, R sub S. All you have to do is scramble it around using the rules of algebra that you learned so long ago. Okay? So remember, you can solve for any of those factors given the other three. Those are all variants on the Myron-Gordon model, okay? And you have survived Chapter 6. Those are the highlights. Again, these lectures are not meant to replace reading and careful study of all of the chapter content, so please make sure you do so, okay? I have asked you in my courses posting to do on pages 140 and 141, I think, read it please, but I believe I said exercise 4, 7, 8, and 9. Try those 4 for me, okay? I am not expecting them this weekend. I'm writing this on the 17th of June, okay? So this becomes part of our next module. I want you to read the chapter, and then this coming week, I want you to try the 4 problems in Chapter 6. I'm going to start a lecture on Chapter 7 very soon, and we'll conclude. We're going to skip Chapter 8, and I do that on purpose because Chapter 8 is mostly review of things you already know, because many of my day students have not taken accounting, and Chapter 8 is a review of accounting for the non-accountants. So I'm going to skip that, and we'll conclude this course by getting into Chapter 9 a little bit, okay? Hang in there. We're on the home stretch. Stand by for material on Chapter 7 as we move into next week, beginning on Monday the 19th. Thanks so much, ladies and gentlemen, and give me your A game on the homework, okay? Bye-bye.